Hi, this is Sandra K. Webster, and I'm presenting an example of how to calculate a paired samples t-test with Excel. You're looking at problem number 4 from my last exam, and before you solve any problem, you really have to understand what the problem is about. How does being in charge affect the arousal produced in virtual reality gaming? Imagine an experiment that used a yoke control design. This is your clue that this is a paired samples t-test design. It's repeated measures, even though it's different people, but they're not independent, they are yoked. So here's what that is. Pairs of subjects experienced a virtual Indianapolis 500 speedway race. One participant was randomly assigned to be the driver, while the other was the passenger. So they are essentially yoked together and experience everything in the experiment as a pair. The driver controlled the game through driving a simulator with steering wheel, gas pedal, and brake. Both participants viewed the game through virtual reality immersion helmets. The scores below are their measures of arousal based on heart rate, beats per minute. And then we've got some data. Now I have copied the data over into Excel, and I have it in these columns as format. This is each pair, and one was the driver, one was the passenger. Those are the heart rates. Well, before I do any t-test, I want to understand the descriptive statistics, and so I'm going to use data analysis. You see it over here, and I'm going to choose descriptive statistics. Okay, and I first want it for the participants who were playing the role of driver. There are labels in the first row. The output range is over here in E2. And I'm going to ask for summary statistics and confidence levels for the mean. And I just say, okay. And then you get all of these statistics. We need to do the same thing for the passenger, so data analysis, descriptive statistics, but we highlight column C, making sure we get them all in. There are 10 pairs, so it would go from C1, which is the label, to C11, which is the 10th one. Labels are in the first row. The output range now is still E. I don't want that. I want it to be not overriding the first one. So I'm going to say G, and I'm typing it in. And I just say OK. And there I've got it for the passenger. So I can look at these and I can say, oh, the passenger had slightly higher heart rate than the driver. And the standard deviation was a little bit equivalent. These are paired samples, and so we don't have to be concerned about a hypothesis of equivalence of variance. It's not relevant. They're connected. So I need to know, is this difference, which is fairly small, significant or not? And in order to do that, I need to calculate a paired samples t-test. So I'm going to do it over here and go back to data analysis. I move down the list alphabetically to the paired sample for two means. Okay. Now, I've done it before, but I'm going to highlight the driver, and I'm going to highlight the passenger. Uh-oh, I've got it in there twice. That will definitely cause problems. So let's just get rid of one of them. Getting rid of both of them. Highlight the passenger. Now I've got them the same. The labels are in there. Alpha is 0.05. The output range is down here. It says B13. This is not where I am. I'm at B18. Let's go to A19. Now you see what it did? It changed my variable 2 range instead. So I have to be very careful. I clicked here, I clicked here, I clicked here, but it keeps choosing other places. Now I've got it. It's just a little glitchy that way. Okay, so here we have the paired samples for two means. The driver mean the passenger mean. We already got that, and you may wonder, why did we need to do descriptive statistics? The output is the variance. We all know that the standard deviation is just the square root of the variance, but it's more convenient to get it up here as opposed to computing the square root again. And we get a lot of other statistics when we do descriptives that can help us understand what's going on with the data. So whenever you do a paired samples t-test, you get Pearson's correlation. That's what this is showing us. And that's just to show you, is there a correlation between the two members of the team? And in this case, it's not. And notice it's not even telling us if it's significant. It's just describing the degree of relationship. It was a negative 0.1. But what we really are interested in is the T statistic. A negative 1.5. It's negative because the heart rates were higher for the passenger, and that was the second thing in the equation. If we would have done it the other way around, it would have turned positive. So if we would have put passenger in first and then driver, it would have been positive. You need to remember to interpret your hypotheses according to what things mean and not so much the sign of the test. When we go down, we look at the p-value. One-tailed is 0.0837. Is that statistically significant? Well, no, it is not less than alpha, which is 0.05. Again, we've got the critical value for one-tail, we've got the p for two-tailed, and we've got the critical value for two-tailed. What you need to report are your degrees of freedom, the t-statistic, and its p-value. But do you report the p-value one-tailed or two-tailed? Well, let's go back to the hypothesis. The hypothesis was a two-tailed hypothesis, wasn't it? It didn't say one would be better than the other. It said, is there an effect? So you need to report the two-tailed p-value with this t-statistic. And that's how we compute a t-statistic for paired samples with Excel.